Welcome once again in a new series of transportation models, trying to get to transportation solutions. In this particular discussion, we are going to look at how to optimize the initial solution of the transportation problem. Specifically, it's a continuation of our previous discussion in transportation models. In our previous discussion, we looked at how to obtain the initial solution using the northwest corner rule, the least cost method, as well as the Vogel approximation method. So when you get the initial solution, what happens is that initial solution may not be the final solution, because remember, our target is to minimize the overall transportation costs. So we need to test to find out if the initial solution you have obtained is in position to minimize the overall transportation cost. That's the whole purpose of optimization. So once you realize that after the testing for optimization has been done, and you realize that the initial solution you got actually does not minimize the overall transportation cost, then all you need to do is to go ahead and optimize the initial solution. So there are two techniques that can be considered to arrive at this particular position, and these are the stepping stone method technique and the modified distribution method, the MODI. So in this particular discussion, our focus is now put on the stepping stone method. In my next discussion, we shall look at the modified distribution method. So let's dive in and we look at the stepping stone method. So we shall go straight and look at the steps that we expect to go through when you're dealing with the stepping stone method. Number one, we need to identify the empty cells. The empty cells, these are routes which don't have any allocation. Okay, we identify them and we name them. Okay, and then from there we need to establish a possibility of creating a closed loop. Okay, from the empty cell across the other filled up cells. Okay, until we go back to the empty cell, and this closed loop should be drawn in either horizontal lines or vertical lines. Okay, horizontal lines or vertical lines, and these lines should be making corners at right angles or 90 degrees. Okay. Now, after drawing the closed loop, the next step is to assign positive and negative signs. Positive and negative signs, okay, to the corners of the loops. So when you're talking of the closed loop, and we've said you're going to make corners at 90 degrees, all right, that means in each of those corners you have made, you should assign a positive or negative sign. You start with the empty cell. The empty cell should be given a positive sign. The one you're trying to test for optimization should be given as a plus sign. Then the next cell should be given a negative sign. Then again, a positive sign, negative sign, alternating them until you come back to the original position, which was the empty cell, which again you'll find with a positive sign. Right. Then after that, you extract the costs. You extract the costs using the positive signs and negative signs that you had earlier reported and allocated to the different corners of the transportation solution. Okay. Then after that, you extract these costs and compute the costs with specific emphasis on the positive and negative signs that you had earlier attached to these particular costs or the particular routes. Okay. So with an example, I'm going to show you how this is done. So once you have done that computation, we are going to get results. Now these results, you should check them to ensure that these results are either positive or negative. Now, when the results are positive, that simply means that particular cell, the empty cell you have just chosen for analysis, or you have just tested for possible reallocation, should not be considered, because a positive answer means that that particular cell will just bring about an additional cost. To bring about an additional cost to the overall transportation system. So your focus should therefore be on those cells that bring about a negative output. A negative output simply means that there's a possibility of you reducing the overall cost of transportation. And that is our point of focus. Okay? That's our point of focus. All right. After that, after doing the computations, okay, what you need to do is to establish of the answers you have got, because you're supposed to do this computation for every empty cell in your initial solution. Every empty cell in your initial solution should be able to be tested in this particular way. So once you test all the empty cells, then you should come up with a set of answers. So pick out the set of answers and check which of the set of answers is negative and which of the set of answers is positive. Focus on the negative, okay? And the most negative number is the one you should focus on, or you can sometimes call it the highest negative number, okay? You should focus on that. And that should be the one which gives you the highest reduction in cost possible, okay? And after you've done that, you reallocate, of course, you reallocate the units of transport to the new cells that you have identified with the negative results in terms of assessment of the costs. You get the negative results. So after reallocation, again, you test to check whether the new reallocation you have just done is actually the optimum or not. In the case, again, you find another negative answer, that's room for more for further reduction in cost, so you should do another reallocation. And you continue doing this procedure until that time when all your answers remain positive. So when your answers remain positive, that means you have reached a conclusion. That means there is no further opportunity for you to reduce your cost of transportation, and therefore you stick to that, and that will become your final allocation of the transportation units. Okay, now that's a brief explanation about the optimization. So let's go to the question and we'll see how this thing is done. Here is our question. We are told that Transcontinental is a transportation company that handles transportation work in Uganda and abroad. In the recently concluded meeting, the transportation manager presented a case to his department that needed optimization. Below is a case presented showing the initial solutions to the transportation project they are about to embark on. Required: provide expert support to the team as far as optimization of this initial solution is concerned. So we are going to follow the procedures we talked about earlier. So, solution. I'm going to copy this and start solving it down here. So this is my initial solution. So what I do, I identify my what should I call them? I identify them my empty cells. So I'm going to identify them and I put them down here. Okay. List of empty cells that need optimization, that need to be considered for optimization. Okay. So this is what we're going to do. I'm going to insert here a small table, something like that. Okay. So I shall say here code to empty cell. Then it's computation. Cost assessment. Call it cost assessment. Cells. Cost assessment of empty cells. So we are going to identify our empty cells very fast and do our cost assessment, and we see how far we can be able to move as far as minimizing our cost of transportation is concerned. So okay, so here we are. The first empty cell we see here is Q1D1. So shall I put it here? Q1D1. Okay. This one here is subscript. Like that. Okay. So from there we have, if you go downwards, all these are filled. Next column, we have Q2D2, Q3D2, and Q4D2. So I'll copy this one, there. So it is Q2D2, D2. Then we have Q3 D2. Then we have Q4 D2. Correct. Next we have Q1 D3. So the next column there. It's also empty. You can see it is empty here. So we shall say Q1 D3. Q1 D3. Next we have another piece, Q3 D3. It's another empty cell here. Q3 D3. Alright, so what else do we have? Q3 D3 is here. Next is Q4 D3. Q4 D3. Q4 D3. Okay, it's here. Then next we have fourth column, which is Q2 D4. Q2 D4. So we need to add some lines here. So it is Q2 D4. Okay, Q2 D4. Then lastly, we have Q4 D4. Q4 D4. So it is Q2 D4. What have I done? It is Q2 D4. Okay, so the other one is Q3 D3. So Q4, I think I'm getting confused here. Q3 D3, Q4 D3. So we're supposed to have had Q4 D3 somewhere. I think I'm just confusing things here. So this one is supposed to be somewhere here. Call it Q4 D3. So we have Q1 D3. Okay, let me first shade them a bit so that I can really separate them. So that they can be confusing. So I'm going to put this line here. Okay, then that's the first column, which has only one. The second column has 3. 1, 2, 3. Then this one has, that column has 3 also. So again, we shade that one. Just differentiate it. Okay, so first column, second column here, third column, and fourth column has Q2 D4 and Q4 D4. This one has Q1 D3, Q3 D3, and Q4 D3. Correct. So this is what we have. These are the 4 columns we have, and we are going to use to compute what we need for. Now, let's start by checking if it's possible to draw a closed loop from D1, Q1, D1. Okay, so I'm going to insert here a closed loop. Okay, let me see if I can do it. Okay, so we start from Q1 D1. Q1 D1 is here. We have an allocation here, so it can come here, but it can't proceed. It can't go this way. Okay, it can't go, but at least we can move from here. We got this particular allocated cell. We go straight to the right up to here. Then you go up. Then you go back. So this is a closed loop anti-clockwise. So we shall start from here up to there. Okay, let me use the one with the arrows. It can be easier for you to see them with arrows. So we shall start from here to here. First line, then you make a corner. When you make a corner, move from here straight to the last item. This also has an allocation. So the only cell which should not have an allocation is the first cell, which is an empty cell you're trying to access. Alright, so from there we move up, let me see. We move up from here to here. then finally go back to where we started from. There we go, close the loop so you can see. Now, we said you are assigning positive and negative signs, so I don't have to assign them, just to know that where we start from it is positive here, this is negative, this is positive, this is negative, and back there it is positive. So which means 6 is positive. So we shall have cost assessment shall be 6 positive, okay, minus, down here where it is making a corner, it is 10 negative, plus, another corner is here 7, minus, another corner is here 3, and then we go back there to positive, so we get an answer and see what we get from there. So we shall say, if you collect like terms together, this becomes 6 plus 7, okay, minus 10 minus 3, which gives you 0. So 6 plus 7 is 13, 10 minus 10 minus 3 is also 13, so 0. So in other words, as far as this particular initial assessment you have done, the root Q1 D1 will bring about an indifferent cost change. Cost is 0. Okay. Let's go to now. We have finished this part here. Okay. So I'm going to remove this one, remove this one, remove this one, remove this one. Then we go now to Q2. This here. Q2 D2. Now Q2 D2, we have to find out where to pass. Okay. We need to find out where to pass. For instance, I need to know how to move. This being, it's difficult to make a loop here, but I'm going to make it happen. So, anti-clockwise loop, we shall start from here. We move to our right, up to there. There is an location here. Then from there, we're going to move downwards up to here. Then from there, we shall move to the left. To the right, sorry, to the right. From here to the right. It is vertical position here. There's an location here. Then from there, we shall move upwards, upwards, upwards. Then from there, we shall be in right angles, right angles. So try to make sure the right angles. I may not be able to draw to scale, but one thing is very clear. I'm making right angles, right angles. Okay, so now from there we move to the left, 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 from here to here, to there. Okay, then from there we move downwards to our original position. Our original position where we started from is the empty cell, which is now down here. So with this closed loop, we can now be able to compute our cost analysis, starting from this particular position. So shall I say the empty cell is 5 minus 11 plus 20, 10, not 20, 10 plus 20, 10. So positive, negative, positive. Then if you go straight to the right, you find a 7 there, but this 7, this is positive, negative, positive. Now this is negative, negative 7. Upwards, you find a 3, positive 3. Then if you go across again, you find a 1. 1 is a minus 1. Okay, so if you look at this, therefore, we can do our cost analysis like before, collect like terms together. So it is a 5 plus 10 plus 3 minus 11 minus 7 plus 1. So 5, 10, 3, negative 10, negative 7, negative 1. So there are 6 items that you can see. You say 1, 2, 3, 4, 5, 6, there are 6 items. So 5 plus 10 is 15, 15 plus 3 is 18, 18 minus 11. Okay, 11 plus 7 is 18 plus 1 is 19, so we subtract gives you negative 1. Negative 1, so that is D2, sorry, Q2, D2, Q2, D2. So this shows there's a potential for this particular route. So yeah, this particular route to receive extra units to minimize the overall cost of transportation, okay? Yes, so we proceed. Next we have D3, Q3, sorry, Q3, D2, Q3, D2, Q3 D is here. So let me look at these lines here. Okay, the bit about using a computer here is because you can delete the lines. If you're using a pen, it becomes difficult to do these lines. Okay, so now we go to Q3, D2. Q3, D2 is here. Yeah, so let's find out, do we have a closed loop? Yes, we do have a closed loop. We have a closed loop, so we can start from here. Okay, start from here up to there. They are properly allocated there. Then from there we have another loop. So you can see there's a location here, there's a location there. Then again we go back. Go back, go back, go back. Okay, then from there, move down to where we started from. Okay, so from here to here. So you must make sure that wherever the line is making a corner, there is an allocation except for the allocation, the empty cell that you're trying to assess, okay? That's the only one which is allowed to remain empty. The rest must have something in them. The rest must have something in them, okay? So we compute. Here we shall start with the 12, which is an empty cell. It's 12 minus 7. 12 minus 7 plus 3 minus 1. So 12 plus 3 is 15. Negative 7 and 1 is 8. So this is 15 minus 8, which gives me 7. Definitely it gives me 7. So this is a very high positive answer, which means there's no room absolutely for cost reduction by putting any kind of energy there. Okay? So that is the thing. So we have that one there. Then we have Q4D2. Q4D2. So again we delete these lines, delete them, so we can go to proceed. Okay, so now Q4D4, Q4D2, it is down here, Q4D2. Now here you have to be very careful because Q4D2 seems to be having a challenge, okay, because you see, when you start from here, Q4D2, when you go anti-clockwise, there is no attachment here. Okay, because from here, Q4D2, this one, there's no cornering. This one, you can corner here, come back there, come here, correct? But how far? Okay, so because of that, therefore, we shall say Q4D2, no impossible, or no closed loop, okay? Closed loop could not be established, so we can't compute anything. Could not be established. Okay? So that one is jumped. That's what I was telling you earlier, that a route which has no closed loop cannot be considered for reallocation. Now this one cannot be considered for allocation at all because we don't know the status of that particular route. And the fact that it's even impossible to allocate there is the fact that even the routes may not be that possible to quantify their operation. So let's go to the third column. The third column is here, D3. And the first item is Q1, D3. Q1, D3. Q1, D3 is up here. We have to find how we can make a closed loop there, because we're looking at a possibility of making a closed loop. Okay. So from here, if you move to the left, you find 35 here, but that's where it stops. If you move down, you find 50 here. But unfortunately, again, that is where it stops. I think I skipped out something. It's supposed to be a 5 here, which I think I missed out. I don't know how I missed it out. Yeah, it's supposed to be a 5 here. I missed it. I don't know how I missed it out. But, so with that additional figure, then it becomes even easier to move, because we can move from here, this position, then back this way, then this one, then this way, then this one, then we land up there. We land here. Okay. So we shall start from there. We shall start from here. Where we're supposed to start from? Just go down to that. Okay. Then from there we shall put another arrow. Move this one up to there. So there's another location here. Then from there, move slightly downwards up to here. Hope you're getting this one. Now from there we move to the right. Just from here straight. Then from there, all these corners we are making, there is an allocation, as you can see. And you cannot make a corner without an allocation. And that's why Q4, D4 was considered to be an impossible case, because the available corners could not bring about an allocation. Okay, so from there we move further up. Okay, so again this one is straight, it's also at right angle. Not very much at right angle, but it is at right angle. Okay, so from there I go back to the original position. So we shall move from there to here. So after doing that, you are going to make the closed loop. So we pick out our costs and see how do we deal with them. Okay, so that is Q1, D3. Start from the cell which is empty. This is the empty cell, which is a 9, but it's a positive. Minus a 2, which is a negative. Then minus. Okay, so we have 9 minus 2 plus 11. 11 is here. Can you see 11 here? Then down you have 10, so minus 10. Okay. Then towards the extreme right, we have another corner there, which is positive 7. Then you go up to minus 3. Minus 3. So that is our situation. Okay. So it is 9 minus 2 plus 11. So this is what we're going to do. We have 9 minus 2 plus 11 minus 10 plus 7 minus 3. So when you put like terms together, we shall say this is equal to 9 plus 11 plus 7. 9 plus 11 plus 7 plus 9 plus 11 plus 7, then minus 2 minus 10, okay, minus 2 minus 10 and minus 3. Okay, get the answer. So 9 plus 11 is 20. 20 plus 7 is 27. 27 minus 15. 27 minus 15 is equal to 12. 12. Okay? So that is Q1, D3. Then from there, we go to Q3, D3. So again, we repeat the procedure. Repeat the procedure. Okay. With the procedure, so we have Q3D3. Q3D3 is up here. So we check if there is a closed loop. We check if there's a closed loop. Q3D3 is here, so a closed loop should be between, let me see, if we move from here up and right and down and back, that is how we're going to get a closed loop there. So we shall say from there we move upwards to this allocated route here, then we move to the left, move like that up to there, then we move downwards up to here, then we move to the right, back to where we started from. So this is our closed loop. So again, assign positive, negative sign in an alternating manner. So we shall start with where we started from. That is a 4 minus 2, then plus 11. Remember, I'm just adding the cost and subtracting the cost. So it is 4 minus 2 plus 11 and minus 10. So if you put like terms together, it is 4 plus 11 minus 2 minus 10. So 4 plus 11 is 15. 15, 2 and 10 is negative 12. 15 and 12 is 15 minus 12, in other words, is 3. Okay. Then we remove these ones as usual. So we remove these ones here, remove that one. Okay. Then from there we have Q4D3. Q4D3 is down here. Again, we find out does it have a closed loop, and I can see it has a closed loop. It's very easy to get one. Just start from here. Okay, just start from here. You move up to the position there. Again, this is a place of where there's a location. So you move to the left to that position there. Then move downwards. Located position there, then back to the right, so to where we started from. Now again, cost and assessment. We start with 0 minus 2, okay, minus 2 plus 11 minus 0. Okay, 0 is here, minus 2 plus 11 minus 0. Okay. Like terms together, this becomes 11, sorry, of course, 11 automatically gives me, I think it's a 9, what I'm seeing there is a 9, because 9 plus 2 is 11, so it's a 9 here, that's a 9 answer. Alright, then we remove now this which I've just drawn, remove these ones here, remove this, remove that, and remove that. Okay, so Q2D4 is here, Q2D4. And again, we check, do we have a closed loop for this particular root? Do we have a closed loop? And I think we do have a closed loop. You start from here, and you move to the right, to the left, sorry, up to here. There's an allocation there, so you have to pick a corner at that point. Then you move downwards to just slightly 1 meter. One box, not 1 meter, 1 box. Then to the right. There's another location there. Then back to the original position. The empty cell which needs assessment. Okay. So from where we started from, it's 8. So it is 8 minus 11, where we made the corner from. Okay. And plus 10 minus 7. Okay, minus 7. So this is 10. Okay, so it's actually 8. 8 plus 10 minus 11 minus 7. So that's 18 minus 18, which gives you 0. Okay, it gives you 0. And lastly, our last empty cell is, okay, our last empty cell is here, Q4D4, which is down here, Q4D4, and again I can see there's a very clear closed loop there which you can have. So we make our closed loop, which is from here to there. See, you can see where my arrow is moving. Then we move to the left up to there. Then we move downwards, downwards, downwards up to here. Then we move to the right up to there. We have a closed loop. So from our starting point we have the 0 minus 7 plus 10 minus 0. So this becomes equal to 10 minus 7, which is equal to what? To 3. So if you analyze these items, there's only one that is going to be positive for us, and that is item there. This is the only one that is going to bring about a reduction in the cost of transportation, because it has a minus 1. It has a minus 1, so we need to extract that particular section and see how it can be, we need to extract that root actually, extract that root and see how it can be able to what? It can be reallocated, how the items in that particular route can be reallocated, okay, with the intention of minimizing the transportation costs, okay, with the intention of minimizing the transportation costs. The intention of, I'm going to show you how that one is done. So I'm going to extract this particular table, okay, with all its contents. I take it down here. So we're going to say now reallocating units to be transported. So put it there. Now pay attention to this particular section. I want you to pay attention because it is the area which sometimes can confuse many people. I want you to now look at I'm going to put the route we used. and how we are going to effect the change. So Q2 D2, Q2 D2 is here, Q2 D2 is here, and let's see the route we took. The route we took is 511, so we are taking this route here. From here we went this way. Then we looked for a closed loop, which we found, and we moved downwards. Okay, what's happening? Okay, moved downwards from here. We moved downwards to this particular position here. Okay, that's what we did. Then we moved to the right. Okay, up to there. Then we moved up to there. There's another location there. Then from there, what we did, we moved to the left. From here we moved up to here. Then after that we moved downwards up to here. That's what we did. Now in this closed loop, there's another thing we talked about, and that is allocating the negative and positive signs. Okay, starting with this particular position, where we start from is positive, then negative, then positive, then negative, then positive, again negative, then back here positive. Okay, so let's now attach those signs. So if I say this is positive, okay, and this is negative, and this is positive, and this is negative, and this is positive, and this is negative here. So what is going to happen is that I'm going to pick the number, the lowest number, but which is negative. The number which is negative but low. The lowest negative number, that's what I'm going to pick. Then that number, I'll rotate it in the loop, okay? So that it is removed where it is negative and is added where it is positive. So for instance, I look at the negative figures. It is negative 5 here, there is negative 35 here, there is negative 10 here, okay? And that's it. Positive is 60, there's empty cell which is positive, and positive 35 here. Okay, so we have 60, 35 positives. We have this empty one which is also positive. Negative, we have negative 35, negative 10, and negative 5. So the smallest negative answer, the value you have there is 5. So we shall rotate the 5 in the sense that where there is a negative, we remove 5. Like now here we shall remove 5. Okay? We remove the 5. Where there is a positive, you add a 5. So like here, we shall add the 5. Okay? Then here, we remove the 5. Okay? Then here, we add the 5. Then here, we remove the 5. Then here there's a positive, we add the 5. Okay, so if I do this particular operation successfully, we shall have a new matrix as shown below. This matrix shall be repeated. Now here we shall just draw it. So I shall say a renewed matrix. So this is the new matrix after the allocation. Okay, after the allocation. Okay, so let's now get the final figures. Now that you have put these figures in red, what you're going to do is remove these arrows now. No longer need the arrows. The arrows are just to show us the loop, which we did. Now we're going to put the new figures. So 5 minus 5 is 0, so this becomes empty here. 35 minus 5 is 30, so it becomes 30. 35 plus 5 is 40, this becomes 40 here. So if you add it across, 30 plus 40 is 70. Then this is plus 5, 0 plus 5 is 5, so this becomes 5. 60 plus 5 is 65, so this becomes 65 here. Then last we have 10 minus 5 is 5, so this becomes 5. So this becomes a new matrix, and if you add them through, you see they're balancing very well. 65 plus 5 is 70, 30 plus 5 is 35, 65 plus 20 is 85, 50 is alone, 50 plus 5 is 45, so everything is okay. Now at this particular position, now we are going to repeat this is now the new matrix, which we expect it to be optimal, but as I said earlier, you can't be so sure. So what you're supposed to do is to do another optimization. So you're supposed to carry out another optimization to confirm that the new matrix you got is actually the optimum position of the transportation matrix, position of the transportation matrix. So what you're supposed to do, therefore, is to redo this particular computation. But this time around, you're going to check the new cells. Okay? So we're going to use new cells. So redo the optimization assessment. The optimization assessment or check. Okay, that's what I'm going to do here right now. So I'm going to redo this. Remove all this because this was now old. And let's first check if these cells need to be repeated or not. Let me see. So if you look at the first column, we have two cells this time around. We have Q1 D1 and Q2 D1. Okay, so this is now first column. Then second column we have 2 again, which is Q3 D2 and Q4 D2, and the rest I think I did not change. The other column we have third column we have Q1 D3, Q3 D3 and Q4 D3, then Q2 D2, sorry D4 and Q4 D4. Now let's do our closed loop and see if there is any possibility of minimizing our costs even further. So for Q1 D1, let's see if we can get a closed loop. So from here, Q1 D1, we shall move from here, and yeah, I can see the closed loop is there. The closed loop is there. Let me see. From here, we shall move downwards up to here. Then we move to the right. Up to here. Then we move upwards up to here. Okay. Then we move to the left, sorry, up to there. That's a closed loop. So if you have to do this, assign positive, starting from here is positive, negative, positive, negative, positive. So we shall have 6 minus, I'm dealing with costs now, minus 10 plus 7 minus 3, and that's what it stops. So this becomes equal to 6 plus 7, okay, minus 10 minus 3, which of course gives you 13 minus 13, which is equal to what? To 0. So Q1 D1 will not give me any additional to actually be in different position if I'm to allocate there. So we need to be very careful there. We can't reallocate that particular position because it will cause us problems. Just next is Q2 D2. So as usual, we're going to remove these ones. Then we do another loop and see if you can be able to get anything. Yeah, it is there. So let's do it. So from here we shall move downwards up to here, then to the right, then upwards, then to the left, correct, then downwards to there, then finally to the left, back to where we started from. Okay, that's the loop. So this is an empty cell, being an empty cell, so we shall say start with 11 positive minus it's supposed to be, we're supposed to remove these colors, sorry about that, put the black, so we start from here, 11 minus 10, okay, plus 7 minus 3, okay, plus 1 minus 5. That's what we have. Now let's check if this one gives us a positive or negative answer. So this, if you correctly turn together, this is 11 plus 7 plus 1, 11 plus 7 plus 1 minus 10 minus 3 and minus 5. 11 plus 7 is 18, 18 plus 1 is 19, this is 19 minus 18, which gives us 1. So there is no room for any cost reduction there. So we go to next. So we finish the first column. Go to the next column. Okay. Next column is Q3 D2. Q3 is here. D2, yeah, correct. So we find, can we have a cross loop there really? Can we have a cross loop? Let me see. If we move to the left, we can move downwards, but there's no connection here. If we move up this way, we can move up to there, then there. Yeah, we can have a cross loop. Correct. Cross loop is there. So we shall do like this, and we say, alright, from here we move to the right up to here. There's an allocation there. Then we move upwards up to there. Then we move to the left up to there. Then we move downwards up to there. Okay, like that. So there we have our closed loop. We are going to compute, starting from the empty cell here, of course, it's 12. It's 12. Okay. Minus 7 plus 3 minus 1. Okay, you see where the 12 is here? Minus 7 plus 3 minus 1, which should give me 12 plus 3 minus 7 minus 1. This should give me 13 plus 3 is 16, minus 7 plus 1 is 8, so 16 minus 8, which is finally equal to what? To 7. Okay, so 7. Now next we have Q4 D2. Again, we need to check if this has a closed loop. Unfortunately for this, there is no closed loop. Q4 D2, no closed loop. No closed loop. It's not possible. So we jump that one. Go to the third column. Third column is here. Q1 D3. Q1 D3 really does not change. It is the same. Q1 D3 actually all these remaining ones have the same as this. They have the same. You see? Q1 D3 we got anyway, there's nothing wrong with doing this thing. So Q1 D3 is here. Q1 D3 is there. So let's get a closed loop for Q1 D3. Closed loop for Q1 D3. Q1 D3 is here. So let's find out what kind of loop we can get out of it. This is very easy actually. It's straightforward. So the loop we have here is just from here to this particular corner. Then we have the one going down up to here. Then we have the one going to the right up to here. Then finally upwards. That's Q1 D3. So starting with the empty cell, we shall have 9 there. 9 minus 1 plus 5 minus 2. Which gives me 9 plus 5, 9 plus 5 minus 1 minus 2, which gives you 9 plus 5 is 14. Okay, 1 and 2 is 3, so 14 minus 3 is 11. Okay, so that part is done. So we go to the next. So next is Q3 D3 down here, Q3 D3. Also for this seems to be straightforward, though it takes a longer route. Yes, longer route. So we're going to have it from here. We move to the left, up to here. Then we move upwards. Up to here, then we move to the left, up to here, then we move downwards, up to here, then we move to the right, up to there, then you go back to our original position, downwards, up to here. Okay. So with this closed loop now we shall have starting with the empty cell, it is 4 minus 7, okay, plus 3, okay, minus 1, okay, plus 5, minus 2. This 4 is here, minus 7, plus 3, minus 1, plus 5, minus 2. So let's see what we get. Correct like terms together, it is 4 plus 3, okay, plus 5 minus, okay, minus 7, okay, minus 1, minus 2, minus 7, minus 1, minus 2, 4, 3, 5. So 4, 3, 5, that's 5 plus 3 is 8, 8 plus 4 is 12. This other side you have 7, 1, 2, 7, 1 is 8, 8, 2 is 10. So 12 minus 10 is equal to 2. 2, that's the final answer, 2. Then this part is done. So then what is supposed to be next is Q4 D3. It is here, Q4 D3. Q4 D3 again, this one has a closed loop, but let me see. Okay. If you move to the right, it is empty. The left you have this one. You have this one. And there's no connecting here. This one should also be another empty because I don't see a connection there between the different routes. Okay. This also should not have a closed. This doesn't have a closed loop. Does not have a closed loop. So as you can see from here, Q43, if you move upwards, just finds this one. You find another closed loop here, but that's where it stops. There's nothing to connect it with. On the right, nothing to connect it with. The left, you have this one and this one, nothing to connect it with. So we have no closed loop for this one. Okay, so now we have what we call Q2D4. Q2D4, here we go, Q2D4. This one is a very good closed loop, it is there. So we shall move upwards, up to there. Okay, we move to the left, up to here. Move downwards, up to here. Then move, okay, not right. Move to there. Left up to here. So this is the closed loop now, closed loop. So in this particular closed loop, we shall now get Q2D4. Q2D4, we shall start with 8. That's where the empty cell is. 8 minus 3 plus 1 minus 5. This is cost assessment, remember? Cost assessment, so plus 1 minus 5. So this becomes 8 plus 1. Put like terms together, then 3 minus 3, sorry, minus 3 minus 5, minus 3 minus 5, so this becomes 8 plus 1 is 9, 3 and 5 is 8, so 9 minus 8 is positive 1, positive 1, okay, then lastly, we have Q44, so let's do that one as well, as we conclude this assignment, Q44, so this one is a very good closed loop, very good closed loop. From here we move to this particular position here. Okay, then we move upwards. It is supposed to be anti-clockwise. Anyway, whichever, as long as it is a closed loop, it doesn't matter really. Go back there. And then back to where we started from. That's our closed loop. So from the empty cell we say 0 minus 0, okay, plus 10 minus 7, okay, or 0 minus 7 plus 10 minus 0, whichever the case may be. So this becomes 10 minus 7, which equals to what? 3. So as you can see in this revised cost assessment of the empty cells, you see that all of them are positive, except the ones you cannot get, where you cannot get a loop. Now this gives you one possible meaning that the cost that we currently have, based on the reallocation we did, see the reallocation we did was here, this reallocation here. When we did reallocation here, we came up with a new matrix. So we have tested a new matrix to check if there's a possibility of us reducing cost further, and we have realized that there's no possibility of us reducing cost any further. So we are maintaining this particular position. And so on this particular basis, that you can make a conclusion that this position that we got is the optimum position. So this position is the optimum position. Okay? Yes. Now, based on this, we can go ahead and compute our total transportation costs and even compare it with our original initial solution that we had before we did this optimization, and check whether indeed our costs have reduced as a result of this reallocation. Right, so what we are going to do is we're going to compute the cost before we started. This is the original position. This was the original position. So let us compute the cost before we started this optimization process. Okay, costs, total transport cost before optimization. total transport velocity computation of total transport costs before optimization, and we see what we have. Okay, let's see. So I'm going to extract the initial matrix. This is the initial matrix we had. Okay, and I put it down here and I see what we get. Okay, so at this particular point, what I'm going to do, I'm going to extract the cost and the units, okay, per route. Let me see, I think we should do it this way. We shall begin with the route, okay, and the cost computation. We shall add another output of the computation. Okay, so this will be our table. Okay, so the first route we have is this one here, before the allocation, of course. That is the Q2 D1. So if I'm to copy from here, just paste it here. So it is Q2 D1. Okay, and this cost computation here is 5 times 5 is units times 11 the costs. Okay, 5 times 11. Right, so let me see, what is this? Right, that's fine. Next we have Q3D1. Q3D1 is 60 times 10. Okay, then from there we have Q4D1. Which is 20 times 0. Okay, then we have Q1D2. Q1D2 is 35 times 1. 35 times 1. Then next we have Q2D3. Because this price is empty, so we're not going to consider it. So Q2D3 is here. And this one is what now? Q2D3 is 50 times 2. Right, so we have 50 here times 2. Okay. Next we have Q1D4. And I think we need one more row downwards here. Okay. I think I need to do something here. Okay, you don't need to go down there. Okay, that will work, I think, for now. Correct. Now we have 50 times 2. We finish it on Q2D3. Then we have Q1D4, which is Q1D4 is 35 times 3. Then we have Q3D4, Q3D4, so Q3D4. that is 10 times 7. Alright, so these are the initial computations. So we shall say these are subtotals, also subtotals. Then we shall add another what, like that, another column, which shall give us a grand total. Okay, a grand total shall give us a grand total in terms of costs. Okay, so I'm just going to mark these ones, push in the middle. Yeah, that's it. So get our calculator. We start with the first one. 5 times 11, it is 55. This is 55. This is 600. Okay, let me just do them in the middle. It should be in the middle. That's fine. But the subtotal must be to the left, the right, sorry. So this is 0, this is 35, this is 100, this one is 70, 5 times 3, 35 times 3, just use the calculator, 35 times 3 equals 105. So at this particular point you do total addition, so we shall say, okay, 55 plus 600 plus 0 plus 35 plus 100 plus 105 plus 70, which gives me 965. So total 965. That's the grand total in terms of the total costs of my transportation. So in other words, in the initial, before optimization, this is the position we had, 965. Now let's redo this very computation, but using the new matrix. Okay, so I shall say the same thing. Computation total cost, this total cost here, computation of it, and now using the new matrix. Okay, so I shall say here, computation total transportation costs using the new matrix. To see actually what happened, what changed. Okay, so we have this one, copy, and you paste it here. Correct. Now this is the new matrix, so let's copy the other computational section, this one here. So we're also going to replicate it down here. So, but this time we're going to remove all these items because they are not going to be there. So let's see, you have Q1, D1 empty, Q2 empty, it goes to Q3. It's supposed to be Q3, then Q4, okay, then we have Q1, D2, then we have Q2, D2, Q2, D2, then Q3, Q2, D2, Q2, D3, then Q1, D4, then Q4, sorry, Q3, D4. Captured all the necessary roots. So let's put the figures now. Q3 D1 is 65 times 10. So put here 65 times 10, which automatically gives you 650 here. Okay. Q4 D1, it is 20 times 0, which gives you 0. Okay. Then Q1 D2 is 30 times 1, which gives you 30. Then Q2 D2 is 5 times 5, which gives 25. Okay, Q2 D3 Q2D3 is 50 times 2 times 2, which gives you 100. Okay, so Q1D4 is 40 times 3, which gives you 120. And lastly, we have Q3D4, and that is 5 times 7, which gives you 35. Now, when you add this, you see what we get. We shall have 650 plus 0 plus 30 plus 25 plus 100 plus 120 plus 35 gives you 960. 960, that's what you're going to type here. 960. Now comparing with the other figure we got earlier, we have reduced our cost by 5. And we happen to be at optimum level. Before we had 965 and now we have 960. So really our operation has managed to save the organization 5, I don't know if these are shillings or dollars, okay, but most likely they could be dollars, they're very few small, so $960 are now saved as a result of this process of optimization. So this is how you optimize transportation models, okay? Yeah, so in your free time, you can try as many questions as possible, take the same procedures, take the same steps, okay? Make sure this is the, okay, not make sure, but remember that this is supposed to be a repetitive process with an intention of ensuring that by the time you reach the final conclusion, there is no option for you to reduce your costs any further. Okay, you are supposed to continue computing these cost assessments of the empty cells so that you end up with negative answers. And that's the time when you can say I've reached the optimum level of my computation. Okay, yeah. So that's it. Bye for now. Till next time.